Hi, Vimman75 here. In this video, I'm going to give you an introduction to the particle system inside of Nodit. So it's going to be just a basic example of how to use the particle system. So let's start off by creating some of the nodes that we need. So we'll start off by creating a particle emitter. And we're also going to need a solver, so a physics solver. And these nodes have a lot of inputs, so it's a bit hard to tell what it is that we're going to be plugging things into. So to make it easier, I mean, you can obviously always just move your mouse over the inputs and that will show you, but it's much easier if you hold down or if you click V or click this button on the toolbar, and that just enables verbose mode, which allows us to clearly see the inputs. So primarily we need the particle emitter. We also need the physics solver. We're also going to need another very important node, which is called delta time. And this node will allow the particles to be able to propagate through time. So let's go ahead and make a delta time node. And the delta time node gets plugged into the delta time. And then the physics solver has an input for emitters. And so the particle emitter, we're going to plug into the emitters here. The next thing we're going to need is we're going to need a draw node. Now, for particles inside of Nodit, we can have them drawn using two nodes. We can either draw them as points or we can draw them as streaks. In this introductory video, we're only really going to start off with some points. So I'm going to need to draw points. Now I can actually just go in here and plug this directly inside the physics solver. I can plug this directly to the points, but this isn't really going to give me any outcome. The reason why is because the physics solver and the particle node, they have a lot of attributes. And so this dictionary output is not going to precisely give me the attribute that I need in order to draw the points. So if I move my mouse over the physics solver and I hold down H, you can see that I have these extractable attributes. And the one that I require in order to see the particles be drawn by the draw points is the actual pos attribute. Now, in order to do that, I'm going to need another node, which is called the extract particle. Um, extract particle attributes node. And so I can plug this directly from the physics solver into here. And this node is special in the sense that if you double click it and you check it in the node editor, you can see that it has a drop down. And so in this case, I can get access to any of my attributes and I want pos. And just because I might have more than one of these attributes, extract particle attributes inside of Node, it's probably a good idea to name it. So I'm just going to call that pos. And now I can plug this into my draw points. So the pos of each particle is now going to be drawn as points. In order for me to see this, I need to enable the visualizer, which I'm just going to dock over on the left here. And so now, because I've got everything that I need, I've got my particle emitter, I've got my delta time, I'm extracting out the pos and I'm plugging that into the draw points. I should be able to see some particles, providing I actually do have my draw points selected, which I'm going to pin. Okay, so there you go. So you can see that I've got my particles now being drawn as points, which is fantastic. Okay, so that's really useful. Now let's imagine I wanted to also add some color to these particles. Right now they're just the default white. If I wanted to do that, there's a few ways I can do it, but the first thing we need to do is we have to decide how we want to introduce color to our particles. So if I was to double click the particle emitter, if I wanted a constant color, I could just go into the initial color, global X, Y, and Z, which represents red, green, blue. And right now that's why they're white because That's the default, but this color isn't actually being used yet because the draw points you can see has a color input as well. And right now, if I was to go here and let's just say I was to go and make the only the X1 and just turn them off to 0, well, you would assume that that would be red, but right now it's not red. And the reason why is because the draw points also needs to know the color. So what I need to do is I need another one of these nodes, which is the extract particle node, which I can just duplicate. And I'm going to rename this one to color so I know what it's doing. And I'm going to plug from the physics solver, I'm going to plug that into the color for the extract particle attributes and swap this over to color. And now I can plug this also into the color points, and that should now, in theory, you'll see it will. Oh, and I forgot to change this to color. So let's just do that. And there we go. So now you can see that the color is being passed through. And I can wrangle these attributes, which would be a more advanced video where I can intercept these attributes and do things with them. But right now, I'm just it's just a pass through, and I'm passing that red, which was coming from here. I'm grabbing it in the extract particle attribute, which is color, and I'm plugging it back into the draw points. And now this is a little bit boring. So instead of using the internal attribute for the particle system, I might have a ramp being used to color the particles over time. So I'm just going to stop this and I'm going to create a ramp. And for this ramp, I'll rename it to I'll call it particle color. And I'm just going to change the color of this so that it's not so boring. So I'm going to make the first stop red. And the last stop, I'm going to make that um, blue. And in the middle, I'm just going to add a new stop by double clicking and making that green. Okay, so now if I was to just come in here and plug this into the ramp color, this will be overridden the colors here, so it wouldn't matter whatever I had in here anyway. The ramp will override it. So if I play that through now, you'll see that the color of the ramp is going to be used across the particle lifespan. Okay, so we can add color that way. Now another thing I want to do is the particles are quite boring at the moment because they're just kind of emitting as an omni into the scene, and that's fine, but maybe I want to add some type of a field, like a gravity field or something to my particles so that they're a bit more interesting. So I'm just going to stop that, and what I'm going to do is I'm going to create another node called a gravity force, and you can see that on my physics solver I've got inputs for forces and colliders. So what I'm going to do is I'm just going to plug this gravity force into the forces, and if I rewind and play now, you can see that I've got gravity. I might just disable the grid and the origin just so it's a bit easier to see what we're doing. But you can see that we've got some gravity, which is very cool. Another thing we can do is, because in a lot of cases, you might want to add more than one type of field to a particle system. At the moment, I've just plugged the gravity force directly into the forces. But if I wanted to, I might want to add a different type of force, and we've got several. So if I went into dynamics, you can see that we've got gravity force, Newton force, we've got a turbulence field, a uniform force, a vortex field, and a wind force. So let's say I wanted to add in a turbulence field as well. I can go and create that, but you can see because I've already used that input, it would just replace it. So in a situation like this, what I can do is I can create a list. So create list is the is the node that we need. And essentially what this does is it allows us to put in multiple fields in this list, and then we can plug the output of that list into our forces. So I'm just going to rename this to force list, and I can plug the turbulence in and the gravity force in. And instead of plugging the gravity force directly in, we can override the forces with this. And so now this will allow us to have both a gravity force and a turbulence force acting on the particles at the same time. I can mute these at any time as well. So if I, for example, wanted to mute the gravity, I could select it and press M, and I can also mute the turbulence. Um, it's quite clear that we can see the gravity, but the turbulence isn't. So it's probably because it doesn't have a high amount of magnitude or frequency by default. So what we're going to do is the turbulence field doesn't have internal attributes like the particle emitter does. So we have to use data um, to manipulate the magnitude or the frequency. So I'm just going to add a float in here. I'm going to rename this float to Tmag, just short for turbulence magnitude, and I might make this something like 35, and I'll just plug this into the magnitude. When I play it back now, I might just mute the gravity temporarily, and you can see that the turbulence is now definitely working a bit more. And if I was to disable this as well, so just mute it, you can see that the particles start to emit quite evenly without the turbulence field, and when I enable it again, you can see that there's a bit of turbulence there, and I can just unmute the gravity too. Okay, so another thing we can do is I can add a collider, and I can have multiple colliders or a single collider. In this case, I'm just going to add in a single collider. I'm going to stop the simulation. In order to do that, I need some form of geometry. I'm going to create a rectangle in this case. I can't see the rectangle at the moment because I'm only drawing the particle points. So in order for me to see the rectangle, what I'm going to do is I'm just going to leave it over here, and I'm going to create a draw polygons, and I'm going to plug the output of that into the polygon list. And even though I've got that now, I can't see it because I've pinned the draw point. So I'm going to unpin that, and now you can see that I can swap between the particle system and that. But ideally, I'd like to see them both at the same time. So in order to do that, I'm going to use a special draw combine draw layers, and I'm going to plug both of these into this. And if I was to now just click the combine draw layers and pin that, you can see now I can see both of these draw nodes at the same time. The one thing I'm not happy about is there's no collision yet, and that's expectable because I haven't actually plugged the collider in. But where it is I'm not happy with it, the position of it, and also its size. So what I'm going to do is on my rectangle node, I'm going to create a transform node to help me position that, and I'm going to plug that into the transform of the rectangle. And now this will allow me to get my rectangle and just kind of move it down, and I can scale it into kind of more of a plane. Now the reason why the particles are kind of emitting while I'm doing that is purely because of the way that the delta node works. What I can do is I can kind of add a boolean to my scene, which will be quite useful just to kind of reset the simulation. So I'm just going to go in here and add a bool, and I'm going to rename that to reset. And I'm going to plug that into two locations. I'm going to plug it into, first of all, the particle, and also into the physics solver. And essentially, if I just set this to true, basically saying that it's reset, so nothing's going to be seen. And it's a nice way to reset your particle system. So if I'll play it back, you can see that it basically turn that on and off. It will reset the particle system. So it's not connected to the actual time. So if you needed to reset that, you'd have to keyframe it or something. But for now, I'm not worried about it. I'm just going to turn it off and on when I need it. So there's still no collision at this point. And so in order to get the collision, I need to plug this rectangle into the collider, but I can't directly plug it in because I need a special node, and the node is called a particle collider. So I need to get the output of the rectangle shape and plug it into the collider geometry. And now I can plug this into the colliders. Okay, so that in theory should now allow my particles to collide. So if I just rewind it, now you can see that there is some interpenetration. Some of the particles are passing through the object. That is typically due to do with the size of the particle. So if I go back to my particle emitter, you can see that there's initial size. I might set that to 5, and that should probably help. So let's just rewind it and play that. Okay, and so the particles you can see are no longer passing through the collider. They're bouncing. The collider also has a bounce and a friction. Again, this doesn't have any internal attributes, but you can plug in your own data to control that, either an int or float. And just for fun, if I wanted to, I might want to just come over to my transform and just kind of maybe rotate this slightly so we can see the particles begin to slide down that. And one other thing I can do is either by using data to override it, or if I wanted to, I could just set the initial lifespan. So right now the particles are only living for 5 seconds when they all die exactly after 5 seconds. So we can, which I'm not going to explain in this video, but we could add in a PP, a per particle lifespan, so the particles would die at different times. But let's just increase this to 10. So now the particles can live for a little bit longer. And you can see now that the particles are definitely bouncing off the object and eventually dying. So again, this is just a very simple explanation of how the particle system works in Noded. We can also extract out lots of other things. So if I wanted to, I could extract out opacity and mass. Well, mass we wouldn't really need to draw that, but I could extract out a whole bunch of different things, and we can wrangle that data and do different things with it elsewhere. But this is essentially how the particle system works as an introduction um, for Node. And if I wanted to, just like I did, have multiple fields, I can also have multiple collisions. And that's the same as creating a list to have more than one collider. So we're going to leave this video here, and I hope you enjoyed the introduction to the particle system in Noded.